Hello, this is Mr. Mack, and this is a video about margin of error and confidence intervals. Now, as you have seen as we've moved through this, we're moving towards the idea of inferential statistics. Inferential statistics is the area of statistics where we take samples, we study the characteristics of the sample, and we infer characteristics of a larger population from the sample. Now, one of the things about inferential statistics when we take a sample is that there is not a really good chance that our average is going to be exactly the average of the population, or in other words, our sample characteristic is going to be exactly the characteristic of the larger population. But we can talk about whether or not we believe we're close, and how close we believe we are, and how confident we are that our actual population's characteristic is within a certain interval of the value we get from the sample. And those intervals are called confidence intervals. And usually we will put in a percentage with it. For example, we'll say we're 95% confident that the population characteristic falls in this interval. And that would mean that out of every 100 times we were to take that sample, 95 of those 100 times, our population characteristic would fall within that interval. You've got to understand, though, that if we say that we're 95% confident, then about 5% of the time, the population characteristic does not fall within that interval. And, okay, so let's take a look at an example here. If a sample is selected randomly, taking care to avoid bias, we can be confident that the sample represents the whole population. Making inferences from the sample about the whole population is the heart of statistics. Let's say your friend Maria says that you have to have the latest, hottest iPhone. Everybody else already has it. What proportion of young people have the iPhone? We cannot possibly ask everybody in the United States who is between the ages of 12 and 20, but we can take a random sample of the population and calculate the proportion that have the phone. If in a random sample of 1,000 members of our population, 250 have the phone, it still does not mean that exactly 25% of the people ages 12 to 20 have the iPhone. The proportion of young people with the phone will naturally vary from sample to sample. Some of the samples of young people will have more, some will have less. This is called sampling variability, and it's unavoidable. If we knew how much the proportion naturally varied from sample to sample, we could estimate a range of estimates, and that's what we're going to do. Now, this margin of error is frequently reported in statistical studies. You might read in a newspaper that the percentage of teens that have the current iPhone is 23%, with a margin of error of 3%. There's also the probability associated with this number, and it is usually 95%. This means that statisticians can be 95% confident that based on their small sample, that between 20 and 26% of the teens actually have the phone. Notice 20 and 26 come from 23% minus 3% and 23% plus 3%. And we call that the margin of error, or the 95% confidence interval. Okay, I'll let you read the rest of this rather than just reading it to you. Now, one of the things about the confidence interval, the more confident you want to be, the wider the interval will be. If you want to be 99% confident that the true value lies in your interval, then you would have to have a wider interval, while if you were willing to just be 90% confident, your interval could be narrower. And many times it is agreed that 95% is a good compromise between accuracy of prediction and the width of the interval we have. Okay, now we have an example now. Students at a high school will vote to will vote on a proposal to start classes later in the day. According to a survey of random survey of students, 54% of the students agreed with the proposal, and 46% of the students disagreed with the proposal. The survey's margin of error was plus or minus 5%. Does the survey clearly project the outcome of the voting? Well, not clearly, because the interval for our survey would be anywhere from 49% to 59%. Now, if only 49% voted for the proposal, then it would fail. So, no, it doesn't. It says use the interval, use the margin, step one, use the margin of error to find an interval in which the actual percentage of students who agree with the proposal is likely to lie. Well, 54% minus 5% to 54% plus 5% is the interval. And what did we say? 49% to 59%. Now, it does look like it's rather likely, but it's not necessarily a lock. It says use the margin of error to find an interval in which the actual percentage of students who disagree with the proposal is likely to lie. Okay, so if people that disagree with the proposal, 46% disagree with the proposal, and that was plus or minus 5%. So if we subtracted 5% from 46, we would get 41% would be the low end, and if we add 5% to 46, we get 51% is the high end. So the percentage of students that disagree with the proposal probably lies someplace between 41% and 51%. You can conclude that between 41% of all the students, you can conclude that between blank of all students agree with the proposal and between blank of all students disagree with the proposal. Because the intervals overlap, the survey does not clearly project the outcome of the voting. Well, they don't really overlap. They have a common endpoint here, but the idea is both of the intervals overlap 50%. So actually, this would be the interval that we would put here, because they're the students that agree, and this would be the interval we would put here, because they're the students that would disagree. All right. We have another example. A city is about to hold an election. According to a survey of random sample of city voters, 42% of the voters plan to vote for Poe with a standard deviation of 1%, and 58% of the voters plan to vote for Nagel with a standard deviation of 2%. The survey's margin is plus or minus 2 standard deviations. Does the survey clearly project the outcome of the voting? Well, let's see. The standard deviation is 2% for the poll. So Poe is going to have 42% with a standard deviation of 1%. So that would be 42 plus or minus, let's see, survey's margin is 2 standard deviations, so it would be 2 times 1%, we'll say. This is Poe. And for Nagel, we've got 58% plus or minus. Now, the standard deviation of Nagel's survey is 2%, and so we would multiply 2 times 2%. So in this case, it would be 42 plus 2 and 42 minus 2. So we would get 40 to 44% would be planning to vote for Poe, and there here we would get 54% to 62%. Plus, I think 58 plus 4 is 62. Yeah, plan to vote for Nagel. And so in this particular case, we would conclude that it is most likely that Nagel will be elected. Now, before I go to the next page with more examples, I'm going to stop this video and then I will start another one.